welcome you to Lecture 6. This is Lines. My name is Jorge and this is for College Algebra. So there's quite a few objectives for this particular lesson. The first thing is we're going to calculate and interpret the slope of a line. We're going to go ahead and graph lines given the point and the slope. We're going to find the equation of a vertical line. We're going to find the point-slope form of a line. We're going to write equation of a line in slope-intercept form. We're going to identify the slope and the y-intercept of a line from its equation. And then finally, we're going to go ahead and talk about parallel lines and perpendicular lines. So the first thing we're going to talk about is slope, right? So here we have a line. And so let P and Q be two distinct points. Now, the coordinates for P is are x1 and y1, and the coordinates for Q is x2 and y2. Now, as long as x1 does not equal x2, then the slope of this non-vertical line L containing the 2 points P and Q is defined by the formula m equals y2 minus y1 divided by x2 minus x1. Again, as long as x1 does not equal x2. Now, if in fact x1 equals x2, then L is a vertical line, and the slope m of this particular line would be undefined. So here's line L. Here's the points Q, P and Q. So the slope then is rise over run. So basically, when we do the slope, what we're doing is we're looking for the difference in the y coordinates divided by the difference in the y coordinates. Another way of thinking about it is the change in y divided by the change in x, or delta y divided by delta x. So the change in y divided by the change in x. Now, if my two x coordinates are equal to each other, here you can see that we have the 2 points P and Q, and the x coordinate for both of them is x1, so then that's a vertical line, and the slope is undefined. So now the slope of a line may be computed from two different ways. We can go from P to Q or from Q to P, so it doesn't really matter. So whether I do y2 minus y1 divided by x2 minus x1, or y1 minus y2 divided by x1 minus x2, the slope will be the same. So here's an example. So I have 2 points. The first point, coordinates -1, 4, and then the other point is 2, -3. So we have the two formulas that we can use. So using the first formula, we see that we get -7/3. So -3 minus 4 divided by 2 plus 1, which is 2 minus -1. And then the other way, we have 4 plus 3, and then -1 minus 2, which gives us the same, which is -7/3. So the average rate of change of y with respect to x then is -7/3. So what does that mean? Another way of looking at it is that for every 7 steps on in the y-axis, we go 3 steps on the x-axis, so rise over run. So here we have the diagram that shows us different lines. We have L1, L2, L3, L4. And so what happens is when the slope of a line is positive, then the line slants upward from left to right, and that would be the red line or the pink line, L1. And that in this one in particular has a slope of 5/3, which is positive. When the slope of a line is negative, the line slants downward from left to right, and that would be line L2. So that's this orange line right here, and the slope for that particular line is -4. Now when the slope is 0, then the line is horizontal, and that will be line L3, the blue line, and the slope is 0. And then when the slope is undefined, which is L4, that would be a vertical line. So again, slope is 0, horizontal line, line is vertical, slope is undefined, goes up from left to right is positive, goes down from left to right is negative. So here we have, so here's the next example. So we're going to go ahead and draw a graph of the line that contains the point 3, 2 and has a slope of 3/4. So the first thing is that we go to the point 3, 2. So we start there, and then from 2, we're going to go up 3, and that's why we go from 2 to 5. And then for the x, we're gonna go ahead and go to the right 4. So that's how we get from 3 to 7. So rise over run. So I went up 3 steps and I went to the right 4 steps, and that's my slope 3/4. So here's the graph of the line that contains the point 3, 2. And then this one contains -4/5. So the slope is -4/5. It contains the point 3, 2. So here you can see the point 3, 2. So what's going to happen is that I'm going to go down 4 steps because it's a negative. So from 3, again, sorry, from 2, I'm going to go down to -2. And then from 3, I'm going to go over to 8. So my rise was -4. So that's how I went from 2 to -2. And then my run was 5. And that took me from 3 to 8. Now, if I go the other way, I could have gone left 5 steps and then up 4 steps. And that still would have been the graph of the line. The slope still would have been -4 over 5. So here we're going to talk about the equation of a vertical line. So a vertical line is given by the equation in the form of x equals a, where a is the x-intercept, and a is just a real number. So we're going to graph the equation x equals -2. So then what happens is, when we graph this, no matter where we go, x is always going to be -2. So -2, 4, -2, 2, -2, 0, -2, 1 are all points on the line. So we plot those points, and then we can just go ahead and connect it and draw the graph of the equation x equals -2. The next thing is what they call point slope form. And point slope form is y minus y1 equals m times x minus x1. So the equation of a non-vertical line of slope m that contains the point x1, y1 can be given by the point slope form. So here's an example. Find the equation of a line with slope -3 and containing the point -1, 4. So we're going to go ahead and use the formula y minus y1 equals m times x minus x1. And so we plug in the values that we know. So y1 is 4, x1 is -1, and we go ahead and kind of clean it up a little bit. So of course it becomes -3 times x plus 1. We distribute the -3, and then at this point in time we're going to go ahead and add 4 to both sides, and then we end up with the equation y equals -3x plus 1. So the equation of a line with a slope of -3 and containing the points -1, 4 is y equals -3x plus 1. And here's the graph of that line. So the next thing we're going to talk about is a horizontal line. So a horizontal line is given by an equation of the form y equals b, where b is the y-intercept. And so I don't have an example here. Actually, I do. And just remember, so x equals a is a vertical line, y equals b is a horizontal line. So find the equation of a horizontal line that contains the point 2, -4. So in this case, we know it's a horizontal line, so then the slope is 0. Since the slope is 0 and I'm going to distribute the 0, what happens is my right side just becomes 0. So y plus 4 equals 0. I subtract 4 from both sides, and I end up with y equals -4. And here's the graph of that equation. The next thing is we're going to go ahead and find the equation of a line that contains the point -1, 4, and then 3, -1. Then we're going to go ahead and graph the line. So the first thing we have to do is we have to find the slope, and plugging in the values in the formula, we get -5 over 4. Then we're going to go ahead and use the point slope form, and we plug in the values that we know. Now at this point in time, it doesn't matter which point you use. We could have used 3, -1 or -1, 4. We still would have ended up with the same equation. So we go ahead and start cleaning that up a little bit, and then here, this is what they call the point slope form of the equation. So we have to leave it this way. I'm not a fan of leaving it this way, but it does tell us some information about the actual graph, and this is what it looks like. So the point -1, 4, and then 3, -1. The next thing is the slope intercept form, and this is y equals mx plus b, and I actually prefer this one to the point slope form. It's just a little easier to use in my opinion. So here we have an example. So we're going to find the slope m and the y-intercept b of the equation. So the equation that we have is 3x minus 2y equals 6. Then we're going to go ahead and graph the equation. So really what we're doing is we have to rewrite it in terms and put it in slope intercept form. So I have to rewrite that so I can look in like y equals mx plus b. So then the first thing we're going to do is we're going to go ahead and subtract 3x from both sides. And then I have to divide by -2, so I have the y by itself. So after I divide by -2, -3 divided by -2 is a positive 3 over 2, and then 6 divided by -2 is -3. So then here, my slope then becomes, and so there's the point right there, right? That's the graph of the equation. But my slope for this particular equation is 3 over 2, because m is my slope. And then my y-intercept is -3. So 0, -3 is a point on the graph, And then of course I can just go ahead and find a second point in the graph, and here we found 2, 0. And the way that you can find that is you make a y 0 and you solve for x, and that's how they found the second point, which is 2, 0. So talking about the general form or the standard form of an equation, this is what it looks like. So the equation of line L is in general form or standard form when it's written as ax plus by equals c, where a and b and c are real numbers, a and b are not both 0. Another thing is that in order to be written like this, we want a, b, and c to be integers, so no fractions and no decimals. So here's an example. Graph the linear equation. So we have 3x plus 2y equals 6, and we're going to do it by finding the intercept. So the first thing that we do is we make y 0. So when we make y 0, we're going to go ahead and solve for x. So when I solve for x, I get x equals 2. So my x-intercept is 2, 0. So the next thing is I make x 0 and I solve for y. So then doing that, I get 2y equals 6. And then I want to go ahead and divide both sides by 2. So my y-intercept is 0, 3, and now I can go ahead and just plot those 2 points. Now, the next thing that we're going to talk about is what we consider parallel lines and then perpendicular lines. So two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. Now, if two non-vertical lines are parallel, then their slopes are equal and they have different y-intercepts. If two non-vertical lines have equal slopes and they have different y-intercepts, then they are what we... So let's go ahead and look at an example. And let's do that. I'm sorry. Okay, so we're going to show the lines given by the following equation that they're in fact parallel. So we have L1, we have L2. L1 is negative 3x plus 2y equals 12, and L2 is 6x minus 4y equals 0. So the first thing that we have to do is we have to make sure that they have the same slope. So we're going to go ahead and solve for y in both of these equations. So for L1, my slope is 3 over 2, my y-intercept is 6. For L2, solving for y, I get that my slope is 3 over 2 and my y-intercept is 0. So they have the same slope, they have different y-intercepts, so therefore these two lines are parallel. So here's another thing. Find an equation for the line that contains the point negative 1, 3 and is parallel to the line 3x minus 4y equals 12. So again, in order for these two lines to be parallel, they have to have the same slope. So the first thing I have to do is I have to find the slope. So solving for y, I get y equals 3 over 4x minus 3. So the slope that I'm going to use is 3/4. Now, using the point slope form, I get the following. And then the following equation is y minus 3 equals 3/4 times x minus negative 1. So simplifying that, I get my equation. Sorry, this program is acting up today. So then the equation for that particular line is 3/4 x plus 15 over 4. And here's a graph of the two lines. So the next thing we're going to talk about are perpendicular lines. So two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. So in other words, they have to be opposite reciprocals in order for the two lines to be parallel. And I mean perpendicular. And perpendicular means that when they intersect, they form 4 90-degree angles. So here's a visual representation of what we were talking about just now. So we're going to find the slope of a line that's perpendicular to a line with a slope 3 over 4. So I need the opposite reciprocal. So if I have 3/4, then the opposite reciprocal of 3/4 is negative 4 over 3. And so therefore, here's just a visual representation of those two slopes. So here's an example. Find the equation of a line that contains the point negative 1, 3 and is perpendicular to the given equation. So first thing is we have to find that slope. So that slope is 3/4. So then the opposite reciprocal of that would be negative 4 over 3. Using the point slope form, plug in the information that I have, and then I get the answer, which is y equals negative 4/3 x plus 5/3. And then the graph of these two equations is right there. And that's the end of lecture 6 lines. Thank you.